Okay, so today we will be discussing about the external rate of return method. The reinvestment assumption of the IRR method may not be valid in engineering economy study. So for instance, if a firm's MAR is 20% per year and the IRR for a project is 42.4%, it may not be possible for the firm to reinvest net cash proceeds from the project much more than 20%. Say more is 20% and the IRR for a project is 42.4%. So yeah, really siya possible for the firm to reinvest net cash proceeds from the project at much more than 20%. So na siya limit. So this equation coupled with the computational demands and possible multiple interest rates associated with the IRR method has given rise to other rate of return methods that can remedy some of these weaknesses. So, one such method that na pwede is the ERR method. It directly takes into account the interest rate na represented by this E external to interest rate external to a project at which net cash flows generated for required by the project over its life can be reinvested or pwede ko borrowed. If the external reinvestment rate, which is usually the firm's MARS, happens to equal the project's IRR, so MAR is equal to ang IRR sa project, then the ERR method produces results identical to those of the IRR method. Okay, so in general, three steps are used in calculating the procedure. Okay, let's check if okay, here are the steps that are used in the calculation method. First is all net cash flows are discounted to time zero, the present at E% per compounding period. Okay, that's the first. The second is all net cash inflows are compounded to period N at E%. The ERR, lastly, ang third, the ERR, which is the interest rate that establishes equivalence between the two quantities, is determined. Okay, and so okay, the absolute value, when you say the absolute value of the present equivalent worth of the net cash outflows at E%, which is the first step, is used in the last step. In equation form, the ERR is the I% at which is being reflected in this equation right here, where ang RK nimo is the excess of receipts over the expenses in period K. The EK is the excess of expenditures over receipts in period K. Excess of expenditures, this is the receipts, and is the project life or number of periods for the study, and this E right here is the external reinvestment rate per period. Sorry, that's per period. Um, of Here, uh, when we are going to interpret that one in a graphical form, you will see right here nga mao na siya on how to the methodology sa three steps. Okay, a project is acceptable when I% your I% of the ERR method is greater than or equal to the firm's MAR. Okay, so see, ERR method ng I% is greater than or equal to the firm's MAR. Yeah, so of course, we have a decision rule, and I have written this one, mentioned this one on the previous slide. ERR method, the ERR method has two basic advantages over the IRR method. And first is it can usually be solved for directly without needing to resort to trial and error. Second is it is not subject to the possibility of multiple rates of return. Okay, so let's go straight to an example, the calculation of the ERR. So this refers to 5-13. I have already included this on the slide. Suppose that A is equal to MAR, which is 20% per year. What is the project's ERR? And is the project acceptable? So by utilizing the solution, ang solution niya is utilizing equation 5-8. Naatay katong solve for I, relationship to solve for I ni siya. And review this one right here, na-discuss na ni sa topic 3, lecture 1, if I'm not mistaken. So you will be utilizing this functional notation. And then 8K, of course, given na ni siya, no? FA 20% MAR, 5 nga, is 5 years given po. 5 years is given, no? Yeah. So, at plus 5,000 na market or salvage value. So, we have, we can compute nga I prime is equal to 20.88%. Now, remember our decision rule for ERR. Because ang nakuha na to na I prime percent, is greater than the MAR, which is the 20%, then ang conclusion nato is the project is justified but just barely. Okay, line of 20 maghihapon siya, but just barely. Manang naingon siya nga just barely. Next, another example is 5-18. When E is 50% and MAR is 20%, determine whether the project whose net cash flow diagram is this one is acceptable. Notice in this example that the use of E% different from the MAR is illustrated. Like nakaingon na siya daan. This might occur if for some reason part of all the funds related to a project are handled outside the firm's normal capital structure. Okay. Disclaimer siya. So this is EO and E sub 1. This is R sub K. So, okay. So, naa siya 5K diri. Given ang kaninga diagram, no? Given na. So, ang imo na lang buhaton is from the cash flow diagram, imo siya himuan og mga gamiton nimo siya ang from here. I-extract nimo ang mga values. So, that would be 10K sa first pa lang. And na kay 5K here at 1 and RK nga 5K for 2 to 6 EOY. So plugging these values in our kanang equation would result to I is equal to 15.3%. Now, guys, so I prime percent is less than the MAR, which is the 20%. Okay, diba 20% ang MAR, 15.3 ato nakuha. Therefore, what would be your conclusion? This project would be unacceptable according to the ERR method. Okay, next. Okay, so now we will discuss the payback or payout period method. So often called, this is often called the simple payment method that mainly indicates a project's liquidity rather than its profitability. Diba, sa introduction pa lang ani nga lecture is I mentioned that ang payback period will kanang nalay murag brief discussion about it. So yeah, hence the simple payback period is the smallest value. Ani siya for which the relationship is satisfied under our normal EOY cash flow convention. So for a project where all capital investment occurs at time zero, mo ni siya na equation ng atong gamitan. Again, at time zero. So, okay, what else? Sorry, I just have to check. Okay, and then, sometimes, anyway, ang simple payback period or kanisha, katong theta, theta to siya, no, ganina. This ignores the time value of money and all cash flows that occurs after the payback period, simple payback period. Okay, and if this method is applied to investment project in our, I think, katong 5-13 nga example, the number of years required for the undiscounted sum of cash inflows to exceed the initial investment is 4 years. Kung sa 5, katong in reference sa 5-13 na example ha, this calculation is shown. I think I'm going to show you the table 5-2 kung mo ni siya ang ang mga calculation. Only when theta is equal, let me just kuan this one as theta ha, kay theta man siguro gini. Kay simple payback period man ni siya para dili taas. So only when theta is equal to n is the market salvage value included in the determination of the payback period. So naapot tayo kanina equation, the 5-10. Sometimes the discounted payback period nga kanisha is calculated. I mentioned this one. So this is in the one I mentioned is in reference to this equation, where I% is the MAR and capital I is the capital investment usually made at the present time. No, pag pag k is equal to 0, and theta prime is the smallest value that satisfy this equation, smallest value. Okay, so this is what this is the table that I have mentioned a while ago nga diri sa column 3 ang calculation na kani siya, cumulative PW at I is sa 0 pa lang, 0% per year. Through year K. So, kana siya ang iyang mga values. This is the net cash flow and, of course, ang EOY nato, which is, in this ERR method, K siya. And then, I at 20% per year. And then, I at 20% nga cumulative PW niya. Okay. What else? Okay. So, from that table, ang katong theta prime niya is the first year in which the cumulative discounted cash inflows exceed the 25K nga capital investment. Ga-exceed siya. So, payback periods of 3 years or less are often desired in, the US industry sa ilaha. So, pareha sa, in reference sa example 5-13, nga project, ma-reject gito siya, even though profitable siya. So, balikin ninyo. Try to go back and trace and do some kanang comparison. So, so the simple and discounted payback periods are shown in this graph. So, muna siya ang simple and discounted payback periods. Okay. Okay, I think we have one example for the simple payback period. So a public school is being renovated for 13.5 million. The building has geothermal heating and cooling, high efficiency windows, and a solar array that permits the school to sell electricity back to the local electric utility. The annual value of these benefits is estimated to be 2.7 million. In addition, the residual value of the school at the end of 40-year life, 2.7, 13.5, is negligible. What is the simple payback period and internal rate of return for the renovated school? So the simple payback period is 13.5. I'm sorry ha, I haven't completed Monday this one. This is 13.5 over 2.5. Ang rate niya nga 2.7 million per year, which is equal to 5 years. I'm so sorry. I have to correct the PDF na sa LMS. This is fairly good for a publicly sponsored project. The IRR can be computed using the equation. So, IRR ta, that would be the negative 13.5 plus ang 2.7. 13.5 is ang cost niya, no? And 2.7 ang annual value sa benefits. So, P over A, I percent 40, yielding I, which is 20% per year. The IRR indicates that the project is profitable for a more of 20% per year or less. So, ano lang siya? Kuhaon mo kung pila to ang simple payback period niya. And then, i-compute nimo ang IRR. So, yeah. Okay, so I think this is the end of topic 3, lecture 1 about evaluating a single project. So using the payback period to make investment decisions should generally be avoided except as a secondary measure of how quick invested capital will be recovered. Nag-matter siya, factor siya, no, which is an indicator of project risk. Okay, so again ha, ang payback period, kung magamit kag payback period to make investment decisions, it should generally be avoided except as a secondary measure of how quickly invested capital would be recovered. Of course, kung investor ka, mag-mind or mag-matter mo consider dito sa risk. So the simple payback and discounted payback period methods will tell us how long it takes cash inflows from a project to accumulate or equal or exceed the project cash outflows. Ingana siya in general, yung definition. So the longer it takes to recover invested monies, the greater is the perceived riskiness of a project. So to investor, di ba? Gusto ka dali, right, kundi mo mabawi. But of course, if the bigger the project, magkuhan ka, be wise enough to balance ang imong inflows and outflows. Si payback period will tell you how soon or ang time, ang period na magkuan sila, mag-accumulate to equal. Okay, so I hope you learned something. That's the end of this lecture. Thank you.